everything filled out and kind of talk about what we're doing here. All right, so to begin with, we didn't talk about what we call a vertex form. So we're talking about of quadratic equations, and we know that the graph is a parabola, right? Okay, so we learned how to find the vertex with a formula. Now we're going to do what we call the vertex form. So it turns out it's just kind of like this. All right, basically this thing right here is going to be the x value of the vertex, and this thing right here is going to be the k value of the vertex. So you can automatically, when you see a problem like this example 2, tell me what the vertex is without having to do any calculation whatsoever. So here's the way I like to look at this. Tell me what value of x would make x minus 2 0. 2, okay, so that means the x value of that vertex is 2, all right? This number right here is going to be the y value, yes?
Sorry to interrupt, but I don't have this worksheet.
Now, I gave that out last time,
and
I don't have that with me, so what you're going to probably have to do is just take something on paper. Those things are on D2L, so I always put those on D2L, and you can print them out when you're absent, okay? All right, so the other thing I want you to think about is this. Okay, and I would write this down because we learned about transformations. That takes you to the right 2, and that takes you up 3. I would write that down because that's an easy way to understand the vertex. That thing got moved right 2 and up 3. That's the idea, okay? Now, whether it opens up or down is going to depend on whatever's in front of that parenthesis. Since that is a positive there, okay, that means this thing is going to open up. If I put a negative in front of that parenthesis, it turns it upside down and reflects it and makes it go down, okay, like that. All right, so that's how you want to do that. You want to dip vertex, open up or down just by looking. Okay, that's what we're after. Okay, next thing we're going to do is y-intercept, and I would write this down. If you find a y-intercept, you do arithmetic. You let x be 0. So what we're going to do is go to this function. We're going to have h of 0 and just replace the x with 0. So we have 0 minus 2 squared plus 3. Plug it in and calculate it. And that'll tell you where that graph crosses the y-axis. Okay? Y-intercepts are always done the same way. So that's going to give negative 2 squared plus 3. What is that in your head? 7, right? Because that's 4 plus 3, so that's 7. So your y-intercept is going to be 0, 7. Okay, like that. Okay? Now, what we're going to do before we do the rest of this, we're going to go ahead and graph this, because really, if we have the vertex and an intercept, then we're in pretty good shape. So what I want you to do on the graph that I gave you is go ahead and put the vertex. So the vertex is over 2 up 3. Just put a dot there, like that. And then the y-intercept is 0, 7. So you put a dot like that. All right, now it's a parabola. We know it's opening up, so you can actually just make a real rough sketch of this graph by doing this then. So all you need to do is just this. All right, now one thing I'm going to show you, and I didn't show this last time, if you have a parabola, typically what you do is from the vertex, what you do is you go over 1, up 1. I'll explain why in just a minute. And you can go over 2 up 4 and over 3 up 9. Okay, let me explain why that is. Okay, so basically we're doing the square function. What is 1 to the second power? 1. What's 2 to the second? 4. What's 3 to the second? 9. So what you can do is you don't want to just wing in that graph. You want to do this accurately. So what you want to do is start at the vertex. Just go over 1, up 1, and put a dot. Okay, like that. Go back to the vertex. Go over 2, and then 1, 2, 3, 4, up. And that's good enough. That's beautiful. Now we got that right half of the graph like that. Okay? Now go back to the vertex and do the same thing. Go left 1, up 1. Back to the vertex, left 2, up 1, 2, 3, 4. And you got a parabola. Okay, that's it. I want you to understand that when you're doing a squaring function, as you move over an amount, you're moving up the square of that. Does that make any sense to you? Okay, so that's how that goes. All right. Now, the rest of this we're just going to look at. If I want you to find the range, what are you looking at in that graph, X or Y? What's range? This way, okay? Does this graph we drew have a smallest value of Y? A smallest value. Does this thing hit a low point? Yeah, what's that Y value right there? 3. Okay, so it's 3 and above. So if your range is 3 and above, you can just write it either as Y is greater than or equal to 3, or you can do an interval 3 infinity like that. Okay, that's how you do that. The domain is always all real numbers on any quadratic function. The reason is because the graph goes on forever, okay? It just keeps going on forever that way, all right? It's never going to, X can be any number if you're talking about a quadratic function, okay? So what I've done, I didn't really hardly have to do too many complicated calculations to get this done, is I can look at the vertex, I can immediately tell if it's up or down, I can find a y-intercept by very simple arithmetic, and then I can look at the graph and tell the range and domain. Does anybody have a question so far? Okay, because we're going to try to get to know, when I tell you, quadratic functions are the most common functions that you see in like a basic business class when you're talking about revenue and profit and stuff like that. Okay, this thing right here is a low point, so we're going to call that a minimum. Okay, so that's what we're going to look at is a quadratic that's in a vertex form and be able to graph it so we don't have to touch our calculator or anything. We just, make the graphs very easy. Okay, and that's what you want to get a handle of, is look at a function and know how to graph it pretty quickly and efficiently, okay? All right, so let's take a look at this then. All right, let's see kind of what we know on this. Can you guys tell me what the plus 1 does? We know we have a parabola, right? What does the plus 1 do? Left 1. What does the plus 5 do? Up 5, good. So I would write that down. That's just left 1, and then that's up 5. What does the minus do to that parabola? Turns it upside down. Good. Okay, that's like it reflects it. So that's a reflection like that. So that's part of what you're trying to learn is, okay, I got a parabola and that's what it's roughly going to do. All right, so the vertex goes like this. All right, since you went up 5, well, okay, the vertex is 5. Since you went left 1, then that becomes an x value of -1. Okay, so what you do is you want to do this efficiently automatically. This thing is left 1, so that's going to be -1. That's up 5, so it's just 5. So go ahead on your graph and go ahead and plot that point. Let's just kind of plot things as we go. So we go left 1, up 5, like that. That's the vertex. Okay, does this open up or down? Down. Why is it down? There's a negative. Good. Okay. So it opens down. So anytime you see a negative in front of the parentheses, then it's down. Okay. All right. Now a y-intercept, and you'll see me do this a ton today. Okay. You always set x equals 0. That's what a y-intercept is. It's a place where x is 0. So we're going to do -0 plus 1 to the second plus 5. So again, I'm taking my function, replacing x with 0, and you can do the arithmetic in your head. Be careful though. If you do 1 squared, you're going to get 1, but that negative is still there. I see students make mistakes like that all the time, because this, you've got to work that out first. That negative is not being squared. What's in parentheses is being squared. So that would be -1 plus 5, so that's therefore 4. Okay, so that means the y-intercept, when x is 0, y is 4. Okay, that's easy arithmetic. Plug 0 in to find for x to find a y-intercept. So go ahead and plot that point. So that's 0, 4 like that. Okay, now here's what you want to kind of look in your mind. So I want you to do fast graphs. You don't have to get your calculator and stuff like this. It's going down, right? Everybody with me? Why it's going down? Negative caused that. Now, what did I say to do from the vertex to get other points? It's real simple. I said over 1, up 1. But we're going down because it reflected. Then I said over 2, what? 4. Good. Over 3, 9. Okay, so what you're going to do is go over 1 down, and then back to the vertex, over 2, and then 1, 2, 3, 4. That's good enough. Okay, right? So that's what you can draw parabolas very easily. So just go 1, 2 right, 1, 2, 3, 4 down, and that's good enough. You can also do 3 and 9. Then go left. Left 1, down 1, left 2, down 4 like that. And that is a perfect parabola, okay? It's graphed very accurately, okay, like that. Okay? Yeah.
Are there going to be any exceptions to these rules on the test by chance?
No. Okay? What will happen is, and we're not going to worry about this too much, if I put a 2 there, then it starts stretching stuff. So instead of over 1, up 1, it would be over 1, up 2 times 1.
Okay.
Instead of over 2, up 4, it would be over 2, up 8. Because that doubles it. Okay, that's it. All right. Okay, range. Okay, what is y? What kind of numbers is y in my graph? Some of them are positive, some of them are negative. So it's where to where. All the way down there is negative infinity, right? Then where does it stop?
It'd be 5.
5.
It'd be 5.
5 and below.
Or equal to 5.
Right, okay, you'll have 5 and below. So you could either write it like this. You could say x is less than or equal to 5, or you could say negative infinity to 5 with a bracket. Because the y, what's y? It wouldn't be x, it'd be y. So that needs to be a y right there, okay? What is the domain on this problem? It's always the same on this, by the way. Domain is this way. Okay, does this graph go on forever that way and forever that way? It does. So that would be all real numbers. So that would be your domain. Okay, like that. Okay. Is this point right here a maximum or a minimum? That's a maximum. That hits a high point. So anytime your parabola reflects, then you got a maximum. Okay, that's it. Okay. So what we're trying to do is get this vertex form down, so we can do graphs very quickly and efficiently. Okay, so I'm going to let you guys work on the next page 1 and 2 just for a few minutes and see how this goes then. Now, if you guys don't have your printout, you could. I mean, you can either just write on paper or at break, or you can go out. You can go log on a computer and you can print out from D2L. They have a printer right by the welcome thing if you want. Or you can just write it down. So I'll walk around and I'll just kind of see if you know kind of what I'm talking about. It's not that bad. Just got to wrap your head around how the transformations work and so forth like that. But you know it's a parabola, so you at least know how that's going to go. Figure your vertex out and then the rest of the details. Right. That's good. Once you get the vertex, then it's not that bad. Now your vertex is -1, 2, so you're going to be going from that vertex. So see, that's your vertex is right, -1, 2, but then you're going to go, since it's reflected, this one's not reflected. Okay, that's up, that opens up. You have that, okay? So from the vertex, you're going to go like right 1, up 1, right 2, up 4. It's going to go up like that. Okay, you can bring it up on your paper. Okay, got the vertex good. Y-intercept's right. Okay, very good. Vertex is good. Y-intercept's good. Now just start putting together. Remember, once you get your vertex, if it's open up, you're going to go over 1, up 1 from the vertex. Over 2, up 4 from the vertex. That's a quick, efficient way to get that done. Okay? I got a D2L, but you can load it on D2L and kind of just figure those later. Okay? I usually remember to bring those, but I just forgot those last night. Those are mine. -1, 2, up. Up because the number in front of the parentheses is positive. Only time it's going to go down if there's a negative. Okay? Okay, I think you're okay.
Yeah.
Okay, negative 1, 2. It opens up, so you're going to be going from the vertex over 1 up 1.
Yeah.
Over 2 up 4. I like that. Okay. Okay, think you're on the right track? Seems to be. I'm going to see it. Maybe I didn't put it up. Okay, just write it down on paper. Okay. During break, you can go to where they have that welcome thing when you come in the building. They have a printer, and you can log in and print there. You want it. That's a little bit better for you. Okay. My apologies. I just kind of was in a hurry today. Okay, so you're all right. Oh, good. All right, you guys are doing good. So it's always interesting, like right after I teach stuff, students do good, but the minute they walk out the door, what happens? So you got to kind of get, yeah, I didn't put it on there. Just do the best you can for the day. During break or now, you can go out to that where they have the table when you come in. There's a printer, and you can log in D2L and print now if you want.
I'm saying I don't see.
Oh, you don't see it. That's right. That's right. My mistake. My mistake. So that's doing okay. Okay, and your vertex is negative 1, 2, and you're open enough, so you're doing that okay. Okay, you all right?
Thanks, sir.
Okay, yeah, it's okay. Okay, so let's see. Okay, so the good news, I think everybody's getting the vertex. That's good. Okay, and this is going left 1, so it's negative 1. It's going up 2, so that's 2. It opens up because there's a positive in front of the parenthesis. The y-intercept, you just do let x be 0. Do that. So if you did that, you should have got, I think, 3. Okay, so you would get the point 0, 3. So that's the first thing you want to check. On your graph, you would go left 1 up 2 for your vertex. Your y-intercept would be 0, 3. All right. So what you want to do, and I want an accurate graph. I don't want students just throwing in a U shape. I want you to be accurate. So over 1 up 1, over 2 up 1, 2, 3, 4, and then backwards. Left 1 up 1, left 2 up 4. Okay, so that's what your graph is. That's good enough. Just try to get vertex and 2 points on either side of it because it's symmetrical like that. What did you put for the range? 2 and infinity, or you could say x is greater, or y, you can either say y is greater than or equal to 2, or you can say bracket 2 to infinity. Either way, you don't have to put both, just one of the others, but you need to understand there's 2 ways to do that. The domain, I hope you put negative infinity, infinity, because that's always what it is. That'll never change on a quadratic function. And max or min? Min, okay, minimum. So it hits a low point like that. That's it. Now see that once you learn that, you can do this pretty quickly. So you can get a real fast graph of a quadratic that way. Okay, the next one, the vertex, you should have got, it's right 3, down 1, so it would be 3, negative 1. Okay, does this open up or down? That's down. Y-intercept, be careful on this. That would be negative 0 minus 3 squared minus 1. I see students mess up on this a lot. What you really have is negative 3 squared minus 1, but then that negative is attached. So when you square negative 3, it's 9, but the negative reattaches. So you got to understand that. That negative has nothing to do with the squaring. Okay, so that would be negative 10. So that would be 0, comma, negative 10. Did you get that? I see that mistake all the time from students. Square, then put the negative in front in that order. Okay, so now if we graph this, our vertex would be over 3, down 1, like that. It's opening down. So now what you can go ahead and do is you can just go right 1, down 1, back to the vertex, right 2, down 4. I think I got that right. And you can put those things in pretty easily because they're symmetrical. And then you can put the y-intercept to negative 10. Okay, so that's basically how your graph goes. All right? You guys look like you're doing okay. Is there any question? I didn't see any major flaws out there, so that's good. What's the range on this one? What did you put? Okay, negative infinity to -1. The lowest y value is -1. Okay, or you could say y is less than or equal to -1. Domain is always the same, and this one would be a maximum since it hits a high point. Okay, so I just kind of gave you one of each. Okay, all right. Any questions? Everybody feel okay with what you did? Okay, shake your head or something. Okay, thank you. Okay, now what we're going to do is we're going to still work with that vertex form a little bit here, and we're going to write an equation. And the purpose of these exercises is to, if you can do something forward, you want to know how to do it backwards, because if you can reverse something, you're going to learn it better. So all we're doing on this one is we're just writing equations, okay? So what happens on this one is, the first thing is figure out what your vertex is. So your vertex looks like the point 2, 1. Okay, now what we're going to do is we're just going to write an equation for this then. Now the standard form is this. F of x equals a times x minus h squared plus k. So this is how you put this in. Basically, once you find your vertex, the 2 goes in for h. So you're going to have x minus 2 squared. The 1 goes in for k. So we'll have x minus 2 squared plus 1. But there's something we have to do for a. What do you have to do for a in this problem?
Negative.
Thing went going upside down, so you do have to have a negative there, right? Okay, that's how you know that. So the answer to the problem would just be f of x equals negative to reflect it, and then it would be x minus 2 for the vertex, and then plus 1. That's it. All right, so you're just doing in reverse what you just got through doing, okay? That should be how that goes, okay? All right, let's see the next one. What is the vertex? 1, -3, right? Okay, all right, so again, you're going to use f of x equals a times x minus h squared plus k. What goes in for h? 1 does. What goes in for k? -3 does, okay? So what you would get is you would just get x minus 1 squared and then minus 3. Plus a -3 is a minus. Would you need a negative in front of the parentheses? Yes or no? No, because it's opening up. So you would say f of x is equal to x minus 1 squared minus 3. That's your answer. Okay? We're reversing the process. Okay? That's something you want to know how to do as a student. Okay? Just trying to learn the language in the form, that vertex form of a quadratic function. Okay. Now, next one, I'll just give you a minute to see if you can do these. Okay? Just look at the graph I gave you and see what you come up with. If you don't have your handout, you can just look at it. You guys don't have your handouts too. You can get your cell phone out and take pictures, you know, for a record if that's a little easier for you. I don't care.
Will it be video like by today?
Yeah, I'll put it up. As soon as the break's here, I'll put it up there. Okay. Or you can drop by my office if you have time after class. Okay. Okay, anybody tell me what you got on number 1? Go ahead.
Function of x is x minus 2 squared minus 4.
Okay, one mistake. It's x minus minus 2, because see, the formula has a minus in it. So what happens when you do minus minus? There you go. Okay, so what you should have got was x plus 2 squared minus 4. Did you guys catch that? Okay, that's kind of a big deal. You want to do that, okay. Anybody tell me what you got on the next one, please? Throw it out. Someone. Go ahead.
I got f of x equals negative parentheses x minus 3 squared plus 2.
Okay, good. Okay, so you got to put that negative in there. So that would be f of x equals minus x minus 3 squared plus 2. That's it. Okay? The minus minus thing you got to be kind of careful about. That's the only thing that I think probably you wouldn't have caught on that. Some of you might not have caught that. Okay, so let's see. Now we're going to kind of go to graphing calculator. So you want to get your calculator out for what we're going to do next here. Those of you, and not all of you, will go on and take business calculus. That depends on your major, but this is kind of a big deal in a calculus class, so we kind of touch on this idea. So if you're not going to take calculus, then it'll kind of help you because you'll see this all the time in that class. So the first thing I want to do is we're going to go ahead and just put these in the calculator. I'm just going to teach you how to do these in the calculator. So if you brought your calculator, what I want you to do is just go y equals, and we're going to graph the left side. We're not going to multiply it out. You don't need to FOIL it or anything. That's totally unnecessary. Just simply put that in your calculator. We're going to go parenthesis x minus 2, close parenthesis, and then x plus 3 like that. Okay? Now we're going to get a parabola. Okay? And that parabola is going to open up. So I'm just going to go zoom 6 just for the standard window. So zoom 6, then you got your parabola. Okay, well what happens on this problem is this. All right, you're going to notice that you have an x-intercept of 2. So just put a dot on 2. Then you have another x-intercept on negative 3. Does anybody know where that came from? But just by looking at my problem, I'm curious.
Yeah, plus 3 is the over 3.
Yeah, that's that thing right there, right? Okay. Negative 3 plus 3 is 0. That's an x-intercept. The 2 came from there. 2 minus 2 is 0. You're thinking of maybe left-right stuff, I think.
Yes.
What it really is it's really, if you solve the equation x minus 2 is 0, then you get 2. If you solve the equation x plus 3 is 0, you get negative 3. Those are x-intercepts is what they are. Okay? Now, this one I don't care how accurate it is. All I want you to do is just wing it. I don't care because it doesn't matter. Okay? Just kind of wing it. Okay? All right. So here's what the deal is. We're doing less than. You're trying to tell me where that function is less than 0. So you're trying to tell me where are the y values below 0. So can you tell me by looking at the graph where, and I'm talking about x values, what part of the graph are the y values negative, below 0? From where to where? Okay. Positive y there, right? What happens in here? What kind of y values do you have? They're negative, right? So what you have is when you solve this problem with a graphing calculator, what you're doing is you're looking for where it's below the x-axis. And you say the answer in x's. So between negative 3 and 2, that's when that function becomes less than 0. Okay? If that was greater than, then you would be looking where the graph has positive y values, so where it's above. So what you would say with this one then is you'd write the answer like this. So in interval notation, it's real simple. You would just say parenthesis negative 3, 2. Okay, you're telling me the x values that cause y to be negative. Okay, that's the area that I'm concerned about. That's where the graph is below 0. Y is below 0 from negative 3 to 2. Okay, then if you want to write this in set builder, you say negative 3 less than x less than 2 like that. It's less than 0, therefore it's where is it below. Okay. All right, well, let's look at the next one. Okay, so again, I'm just interested in this kind of problem being done on a calculator. So I'm going to go 4 minus x, and then I'm going to put in x plus 1, and just graph it. And this time it's going down. There's a reason why it's going down. So what we have is we have negative 1. You have an x-intercept of negative 1. That comes from there. You have an x-intercept of 4, which comes from there. Okay, and then just wing it. Okay, I don't care that it's all that accurate. It's just that's what we need to know. Okay, Now this one, if you understand kind of what I did on the last problem, well, what are you looking for now? If I'm asking where it's greater than 0, am I looking above the x-axis or below it? Above. So what would be the answer? Where is that graph above the x-axis? From where to where? Yeah, from here, which was -1, and this is 4. Okay, like that. Now, since that has an equal to bar, you're going to use brackets, okay? By now, hopefully you know that that equal to bar is telling you got brackets going on. So that means the answer on this would go like this. So you'd be looking at this region here. So you would just say, in interval notation, it would be between -2 and 4. Whoops, not -2, -1. So that would be -1 and 4. Set builder, you just say -1 less than or equal to x, less than or equal to 4. Okay? Yeah.
What are we supposed to put up? Well, what's supposed to go up on the y1 part? That's above the graph.
Oh yeah, just the part, this whole thing right here.
Oh, that just gets rewritten.
Yeah, all you're doing is that gives you a parabola, and you're interested in where that's either above the x-axis or below. That's the idea. That's all it is. Okay? And I just want to kind of introduce that idea for mostly for people who are going to take calculus. Okay, so all these problems are going to do the same. Next one, again, we're just going to put in this side, and I think we'll just kind of do 2 more together, and I'll show you how this goes. All right, so let's see, just put in y1, put in this in your calculator. So we're going to have x squared plus 7x, and then plus 12, and then just type graph, so we have that. Okay, now this one right here, we're going to do one little algebra thing on here. Now it's a parabola going up. The reason the parabola is going up is because that number in front of x squared is positive. That's why that's going on the way it is. So what I want you to do is we are going to factor this. Okay, factorings are going to be a real big deal in this class. So what's the first term? To get x squared, you do x and x. Last term's 12. Okay, what are your choices on 12? 1 times 12, 2 times 6, 3 times 4. Which one's the right one? 3 and 4. How come? Because 3 and 4 add up to 7. Okay, that's your trinomial. So what you'll have is you'll have x plus 3, x plus 4 like that. Okay, that's factoring. Some of you are doing wonderfully on factoring. I see a lot of students that just got to get that down. You have to. Come by and get help if you need to. Okay, well, this would end up giving -3. That would end up giving -4. The calculator is basically showing you that you have an x-intercept at -4 and you have another one at -3. Okay, if I zoomed on my calculator, you would see it a little bit more clearly. But what's happening on the graph is it's just kind of doing something like that. That's what's coming out on the calculator. Okay? Now, let's see if you're beginning to catch on to what's going on here. All right, this is a greater than or equal to 0 problem. So what are you looking for? Above the x-axis or below? Above, exactly. So you're looking at this area here is where that happens. So where does that happen? Between what and what? -4 and -3, right, okay. Would it be brackets or would it be parentheses? Brackets, good. It's got the equal to mark on it. Excellent. So what you have is you would just say bracket, -4, -3. That's the answer. Set builder, you just say -4 less than or equal to x, less than or equal to -3. That's it, okay? All right? So there's the factoring aspect of this too. Okay, the next one, I'll show you kind of what happens on this one. Now this one I'm not even going to do on the calculator. You can go ahead and do that if you want to, but the key thing that you have to know how to do is how to factor. How do you factor x squared minus 4? We call that a difference of 2 squares. So it's what and what? X plus 2, x minus 2, okay? All right? X times x is x squared. Positive 2, -2 is 0. Okay, so here's what that's going to mean. This is going to generate an x-intercept of -2. that's going to generate one of 2 like that. So put a dot on -2 and put 1 on 2. All right? Now, let me ask you a question. Now, hopefully you're beginning to get this now. That's a parabola, right? What does that -4 do to that parabola? What did we learn? Up or down? Down, exactly. So you're going to have a parabola going like that. It's opening up because that number right there is positive. Okay? So what you'd end up having in this problem is the parabola goes down 4, so your graph would look like that. All right? And on this one, what are you looking at, above or below? Above again. Okay? So where does that happen? Well, this happens like this now. The way this works is it happens when x is less than or equal to -2. So when you're to the left of -2, your graph is above the x-axis. And it also happens when you are bigger than 2. Okay, so we can just say, write that. When x is less than or equal to -2, or when x is greater than or equal to 2. Okay, interval notation, you go like this. You would say -infinity to -2 for that part, and then this part would be 2 to infinity, like we learned how to do. So that's how that goes. Okay, so you got to learn how to write your intervals good. Those of you going on and take calculus, man, you're going to do intervals and stuff like crazy, and deal with graphs and inequalities like this a lot. Okay, it happens all over the place. All right, so let's say I was going to let you do maybe just 2 of these. You could actually do these without your calculator, but if you have a calculator, you can put them in just to kind of get the overall idea. Like the first one, you can figure out where those x-intercepts are. This is something I want people to be able to do in your head. What would make that 0? -4. So you would have a dot at 4. What would make that 0? -1. Okay, you can put it in your calculator if you want to, but you don't have to. And then that part B, you could go through and you could do that one by factoring. So just get you a rough graph and I'll see what you come up with. Now again, these 2 things you can use your calculator on to do your graph. Yep.
Are these both extra ones?
Well, one of them's the answer key. I haven't passed them out yet, but you can go ahead and take one.
Oh, sorry.
Okay? Yeah, that's fine. Okay, so let's see. The first one here is kind of what your graph would look like. You would have an x-intercept at 4, so that gives you 4. And that one gives an x-intercept of -1. And then this one will go down. If you put it in your graphing calculator, it'll kind of go down. I know some of you didn't bring a calculator with you. So roughly, that's what the graph looks like. Okay? This one, you're looking for where it's above the x-axis, because it's greater than, so that means you're looking at this area here. So what's the answer? From where to where? Say something. I'm assessing.
So from -1 to 4.
There you go, -1 to 4. Okay, they're always naming that with the x values. Okay, so what you would say is you would use parentheses on this. So you would just say -1 to 4 would be where that happens. Okay, if you do set builder, you say -1 less than or equal. Whoops, not less than or equal to. You would just say less than x is less than 4. That's how you write in set builder that it's between -1 and 4. Okay. Okay, let me show you how the next one goes. Now I'm going to do this without the calculator. If you factor this, what you would have is you would have x and x to get x squared, 7 and 1 to get 7, and you'd have to have a plus 7 minus 1 to get that 6 out of that. So this would generate an x-intercept of negative 7. This would generate an x-intercept of 1. So it goes like that. Now again, on these problems, I don't care how accurate your graph is, but you need to have those x-intercepts. Okay, you can tell if it opens up or down because that's all that matters. That's a positive, right? So does it open up or down? Up. If that's positive, it's up. If that was negative, it would be down. So again, I don't care about the accuracy. You just want to say, okay, that's roughly what my graph looks like. The x-intercepts are important. Okay, this one is a less than problem. So that means you'd be looking this time below the x-axis. So what's the answer? Where to where? Negative 7 to 1. Okay, so what you would write in Set Builder is you would say negative 7 less than or equal to x less than or equal to 1. Okay, interval is just negative 7 to 1 like that. So that's the idea. Okay, the idea is really simple. You're using your graphing calculator to help you with that. If it's greater than, it's above. If it's less than, it's below. That's what you're doing. Okay, does that make sense to everybody? Tell me. Okay, all right. So let's run through, I think, maybe one more thing before we take a break here. Again, those problems, the graph, the accuracy of the graph, I just need the intercepts and whether it's up or down. So I want to go ahead and do one more thing here and kind of wrap this thing up. So with this one, I'm going to look at intercepts. We're going to look a little bit with a graphing calculator and with a quadratic formula. So I want to kind of show you how this goes. All right, so first of all, we're going to find the intercepts by hand. Okay, and you're going to do this over and over again in this class for lots of different reasons. And this is something you should write down. When you find a y-intercept, all you're going to do is just set the x value equal to 0 and do arithmetic. That's it. You can learn to do this in your head. So what we're going to do is where you see an x on this left side of the equation, just plug in a 0. You can do that in your head. What's the answer to that arithmetic in your head? Negative 8, right. Good. So that y-intercept is 0, negative 8. I'll show you how to do this on your calculator in a minute because I want you to be able to do it with and without technology. Okay. When you find an x-intercept, what you do is you just set the function equal to 0. Okay, so you do this. So what you're going to do is it's already set equal to 0, so we have 2x squared minus 3x minus 8 equals 0. All right, now this is what you got to do, and the quadratic formula is kind of a prerequisite to this class. This is the quadratic formula, so I'm going to go through and show you how you use this formula to get these x-intercepts. So basically, a is always the number in front of x squared, b is the number in front of negative 3, and then c is the number like that. And we're going to plug in the formula, and we're going to use a calculator probably to get decimals on this more than likely. So take your formula and do exactly what that formula tells you to do. You're going to have negative b, so you say x is negative of whatever b is negative 3. Okay, follow the formula, negative b, negative, negative 3. You have a plus or minus. I'll explain what that is in a minute. Under the radical, you're going to take b squared. b is negative 3, so you just write down parentheses, negative 3 squared, and then minus 4ac. So 4 times a is 2 in this problem, and then c is negative 8. Okay, and then it's all over 2 times a, and that's 2. Now, just generally, students, if you haven't done this in a long time, I'm plugging into a formula. So everywhere I see an a, I put a 2 in. Everywhere I see a b, I put negative 3 in. And where I see a c, I put that in. So that quadratic formula is going to give you what those x-intercepts are. Okay. Now, before we do anything on the calculator, we're going to do some simple arithmetic. Okay, like this. So if you have a negative, negative 3, that becomes positive 3, right? Okay, and then we have plus or minus. And then when you do this part, if you square negative 3, that becomes positive 9. Okay, and watch this part carefully because students mess up on it a lot. you're multiplying three numbers, but you have two negatives. So do you get a positive out of that stuff, or do you get a negative? Positive. And negative times negative is a positive. So that's 8 times 8. That whole thing is positive 64. That's arithmetic. So that whole thing's positive 64. And then all over 4, like that. So what you would get is you would get 3 plus or minus, and that would be 7 square root of 73 over 4. Okay? All right, and when you do that, I mean, once you learn how to just plug into the formula, it's arithmetic. You just got to be careful with your negatives. So what I'm going to do now is I'm going to take my calculator. I'm going to show you what I'm going to do on my calculator to get that. Then I'm going to repeat this process and show you how you can get the answer without the quadratic formula. Okay, you can do it either way, but it's important to know the quadratic formula. So what I'm going to do is go to a clear screen, and I just do this like this. So I'm going to do, first of all, I'm going to do 3 plus square root of 73 over 4, and I'm going to round it off. So I'm going to go like this. I'm going to go 3 plus, and I got square root of 3. Or not 3, 73, square root of 73. Okay, so I'm going to put that in, get an answer. Then I'm going to divide it by 4, and I'll just round it off to like 1 decimal. Okay, so that's giving about 2.9. Okay, like that. Okay, then I do the plus minus, then I do 3 minus the square root of 73 over 4, and I get that answer. So I go like this. I go 3 minus, and again I'm going to go square root of 73, get the answer, then divide that by 4 and round it off. So I got to do that numerator before I divide it by 4, so that gives about negative 1.4. Okay, and you got to use a calculator if you're going to get decimals on that. So that actually gives you your intercepts. Most of the time in practice, in the real world, when you're working with this stuff, you don't get nice numbers, you get decimals. So your x-intercepts are 2.90 and negative 1.40 like that. Okay, so that's how you do that. All right. All right. Now, some of you, the quadratic formula, I can just tell by looking at some of you that you maybe had never done that, or I don't know. It's not that bad. Okay, I give you the formula, you just plug A, B, and C in. Okay, now before we take a break, I want to just repeat this problem on a calculator. Those of you that brought a calculator, please do this with me, because you'll understand it better. And I've already written down the keystrokes of how you do this. So a problem like this, I want you to know how to do technology. Okay, so what we're going to do is the first thing is you're just going to put this in y1. We're going to graph that parabola. So we're going to put in 2x to the second, and then minus 3x, and then minus 8. Okay, just get it put in. Type graph. You can go standard graph. I'm going to go zoom 6, and I get the graph. Okay, like that. All right? Yes?
I think you put the points in wrong. It's 3x squared, not 2x.
What did you say?
The points for the graph in the calculator, I think you put them in wrong. It said 2x squared.
Oh, okay. I didn't put the equation in right? That's okay. Seems like I got it okay. What are you talking about with the points?
Well, it's 2x squared on the calculator, but in the equation it's 3x squared.
Yeah, it's supposed to be 3x squared.
3x squared? No, I'm putting this in.
Oh.
2x squared minus 3x minus 8.
I thought you went to B, bro.
I'm okay, I think.
Never mind.
Okay, that's fine. No, that's fine. I just want to make sure I'm okay. So you may have been seeing something different or something.
I was
Okay.
looking at the next problem.
Ah, that's it. Okay, very good. Okay, so here's what we're going to do then. Now, here's what you do. And this is a lot less work than what I showed you. If you want to find an x-intercept, just do this. Just go ahead and graph. We did that. And then type trace. And then type 0. So trace 0. It's going to blink on the y-intercept and give you negative 8. Okay, boom, that's it. Okay, you want to know how to do that by hand and verify with a calculator. Okay, so that's good. It's a little bit more complicated to do the x-intercept, but I do have the keystrokes written down for you, so you go like this. Okay, so what we're going to do on the x-intercept, if we're going to graph it, then you're going to go just follow what I've written down, second trace, then you're going to go to the one that says 0, and a 0 gives an x-intercept. So what you do is get the 0, press enter. Okay, like this. Now, you're going to get a left bound. Your calculator should ask for a left bound. Now, what that means is you need to move the cursor so it's to the left of where that intercept is. So just keep pressing the left until that cursor's up there somewhere. Okay, so you go like this. Okay, so I do this, a little bit to the left like that, then I press enter. See, that's a left bound. Calculators usually will put a line through that. Now it's asking for a right bound. A right bound means move your right cursor until you're a little bit to the right of that intercept. Just a little bit to the right of it. Okay, don't go too far, but just a tad bit to the right. Okay, once you got a right bound, press enter. It's going to say guess. When it says guess, press enter, and that'll give you your x-intercept. Look at that. That is negative 1.4 about. And that's what we got on the quadratic formula, so that matches that right there. Yep.
Mine gets stuck on the second part.
It did what?
Mine just gets stuck on the second one. The one with the second part. It's a guess part.
Doesn't do anything? Oh, yeah, I think you pressed intercept, like you said. So start again, second trace, and 0. I think that's what you did. Yeah, that's what I thought. Okay. Okay, so do that. All right, let's do that next one real quick, just practice one more time. Now you got to start over again on this, so we're going to check the intercept 2.9. So you go second trace, go to 0, press enter. Now get a left and right bound on the other intercept. So I'm going to move the cursor until I'm a little bit to the left of where that intercept is. That's good enough. I'm to the left of it. Press enter. Okay, that's a bound. Get a right bound. Move the cursor until it's to the right of that intercept. Okay, it looks like that. That's good enough. Press enter. When it says guess, press enter, and it'll out will pop your intercept. 2.8, so that's 2.9. Which way would you rather do it, the quadratic formula or just your calculator? That's what I thought. It's the same. I mean, you want to know how to do both ways. Okay, but you can use your technology to get that put together. Okay, let's go ahead and take a break till 5 after, and we're going to wrap that up, and then I'll give you. And if anybody's having any trouble with using your calculator, now's a good time to ask. So if you're having any problem, just raise your hand and let me know. Oh, God, I hate this computer. My computer decided to just crash. That's great. Jesus. Well, let me put it in real quick, and then we'll kind of compare answers. What did you get for the y-intercept? You can actually do that in your head. -8. Okay. Now, I'm going to put this in on this, and then I'll put the answer up on this next one. But my computer on my TI calculator emulator just crashed, meaning I'd have to reboot my computer, and I'm not going to do that. So let me just get this put in real quick. Okay, so here's what I got. And you can tell me if you're on the right track here. So I got -1.1, because it was like -1.08. So that would be one of them. And let's see, the second one. Let's see, left bound, right bound. Oh, crap. It's positive something. My calculator's not behaving. There we go. I got 1.83, 1.8. Does that sound right? Okay. So it goes like that. Okay, you guys doing that? A lot of you don't have calculators, and you need to get them. Okay, you need to use technology in this class. All right. Okay, so that's that. If you have trouble with that, that's something you want to come by my office and let me help you with the calculator. Yeah.
Positive 1.1 and then negative 1.8. How'd you get
On the first one? No, the first one, the intercept is clearly on the left. If you look at your graph, that intercept's in the negatives. So I got negative 1.1. You may have done left and right bound wrong, but that's negative 1.1. How many people got negative 1.1 that did this? Okay, you did something wrong. I think you put your left and right bound in there wrong. Because if you look at your graph on your calculator, then that's going to be on the left side. Okay. All right, so let's see. I want to wrap this up with one business application here. All right. All right, and this is like super important for your test next week. All right, you might want to make a note of that because this is kind of what we're building up, is to be able to do a lot with the algebra we're learning. So this is something to test you over for sure. Okay, so what this particular problem is saying is it says you have a marketing research company, it's selling notebook computers, and then this is what your price demand function is. X is the number of computers in thousands, and it's a wholesale price of P dollars. Okay. Now, a lot of these things, formulas and stuff, we'll talk about this next week. I don't give you because you're a business major. So when you do a revenue, you do X times P. You do the number of items you sell times the price. You got to know that formula. Okay. That's expected, is that you know that formula. So what you do is you take X and you multiply it by P. P I gave you. Okay. That's called a price demand function. So it's 2,000 minus 60x, okay? Do a distributive property like this, so that's going to give 2,000x and then minus 60x to the second. All right, so that means the revenue function, there's nothing to finding a revenue function because I'm going to give you a price demand function. At this stage in the class, that's a given. So you just got to know you take X times P and you got it, okay? And that revenue is going to be a model how the revenue is changing as we produce different amounts of computers. So that's how we do that. Okay, now, let's see. I think my calculator got stuck somehow in here. It's like misbehaving. So go ahead and do this. I'm probably, just to finish this up, I'm going to have to do it on my calculator and just kind of show you what I put in. So go ahead, those of you who have a calculator, put in 2000x minus 60x squared. Okay, then we'll talk about a window. That's another thing that you're expected to be able to figure out in this class, is a viewing window. All right, so let's see, put in 2000x minus 60x to the second. Okay, now you're going to have to adjust that viewing window in some way. All right. I can't show that because I don't want to reboot my computer. It'll take too long. So what I'm going to do on this is the window like this. I'll just write down what you need to put in your calculator. So for your window, you want to press your window button. You're going to put in X minimum. You can either put a 1 or 0 in. I'd recommend you just put a 0 in. And then for X max, you want to go ahead and put in 25. And for X scale, I would just do 5. That way your graph's going to go 5, 10, 15, 20, and so forth like that. Okay, now let's see. So get that put in. Now let me kind of show you what we're going to do for Y. Okay, for Y minimum, we're going to put 0 for Y minimum because Y is the revenue. You can't have negative revenue. That's why I do that. Y maximum, I'm going to take a guess on this. It's probably really big. So let me just kind of take a wild guess on this, and I'll give you something here in just a minute. Okay, let's do this. Okay, let's do like 30,000. Okay, and then for the Y scale, put in 10,000 like that. Okay, and I'll write that up there, then we'll start putting our graph. So get your function in, get your window built, and then we'll start sketching the graph. On that Y, you have to take sort of a guess on that somewhat. Okay, all right. Now, this is how I would want you to draw your graph. You'll be doing this on your test, so you need to know how to do this. This is point blank. You have this same problem on, not the same problem, but very similar on your test. So you would say X there, and that would, you'd have to write like it's notebook computers. You got to tell me what it is. Okay, you don't go into a business presentation with just X and Y not telling me what they are. This is the revenue, like that. Okay, then go ahead and get your scale built. So on X, we're just going to go 5, 10, 15, 20, 25 like that. Okay, for your revenue, you're going to go 10, 20, 30. Now you can put 10K for 10,000, 20K and 30K if you want to. That's pretty common is what you do with that anyway. Okay, now what I'm going to do on the calculator is I'm just going to get like 3 points. Okay. Now, we've been doing this in class a lot of times. What I'm going to do is just, if you get 3 points, I'm good. So I'm going to go trace. So you want to press your trace button, start at 0. If you trace at 0, you get 0. Okay, and I'm just going to label that point. Now, if you're doing revenue, that is always a point on a revenue function, because after all, if you sell nothing, how much revenue do you get? Nothing, right? So 0, 0 is a point. Now, let's take a point that's like maybe trace at like 10 or 20 or 15. I'm going to have you do trace 15. If I trace 15, I get 15 and 16,500. So I'm just going to go over to 15 and approximate where that goes up like that. That's pretty close to the max. Then I'm going to trace at 25. And at 25, I get 12,500. Okay. So I'll just kind of put that in like that. You want to label those points like that, and then this will be 25, 12,500 like that, and then just sketch it in. Okay, that's what I want to see. All those things want to be labeled and just get 3 points, okay? The more the merrier, but 3 is good enough, okay, like that. So you have a relatively accurate graph. Now I did the tracing. Is that working for those of you who got your calculator so far? Everybody's with me, okay? I'm sorry I can't display my calculator, so I'm going to have to kind of finish up this way. Okay, so revenue's XP. Graph the revenue. You're going to do that with a calculator. I don't expect you to do that graph any other way except a calculator. Now, what we're going to do is we're going to do this, and I'm going to try the best I can to explain how to do this. You're going to find the maximum revenue. So I'm going to write down the keystrokes. Well, actually, I already wrote down the keystrokes. So what you want to do is you want to have your graph. Has everybody who's got a calculator got their graph up? Okay? All right. So just do exactly what this tells you to do here. So you want to go second, trace, then go to where it says maximum. So I'm going to go down, I think that's number 4, press enter. That's going to be asking for a left bound and a right bound. So look at where your maximum is. You can see where that high point is. Just take your cursor key and try to get a little bit to the left of where that maximum is, okay? Be safe when you do that, too. I mean, you know, get over there. Make sure that you know I'm to the left of that. So I'm over here somewhere. Press enter, okay? Just move the cursor until you get to the left of the maximum, okay? Now when it asks for right bound, use your cursor key so that you get on the right side of that. So I'm going to get on the right side of that. I'm going to press enter. So left bound, enter, right bound, enter. It says guess, press enter. Okay? Tell me what you got if you're following. I'm just curious. What'd you get?
For X, I got 16.6 and Y.
There you go. Good. Is that working? 16.6, and it was 16,000 something. Is that working? Okay, good. Okay. So that's how you're going to do that. So what we do on this then is by using the calculator, what you have is the max. Let's just write down the point. 16.7, I'm rounding, and $16,666 $2,222.67. Okay, so that's what your graphing calculator gets. You can't do this problem any other way, guys. Okay, at this stage, you have to do it that way. Okay, all right. So what we would say is the maximum revenue, this is your revenue. So that's the maximum revenue that you make. And that happens when you make about, well, you can either say 16 or 17 computers. That's all ballpark anyway. I think that was in thousands. Okay. So if you read the problem, it said the number of computers X is in thousands. So if you produce 16,000 computers, you get $16,660 revenue. That's what that means. Okay, right? So is everybody okay with what I did there? Okay, now you gotta make sure you know how to do this next week. Those of you that take business calculus, if you have to because you're a major, then you look at how calculus does this methodology in a little bit different way. But we want to get the idea of how you can do this with technology. Okay, now a business would like to know what price to charge in order to maximize that revenue. Wouldn't that be kind of what you would want to do? Absolutely. So what I want you to do is write down the price demand function, and that's back at the beginning of the problem. That's 2,000 minus, and what was that, 60x, okay? 2,000 minus 60x. Okay, what you're going to do is you're going to plug in this for x. Okay, because we just figured out that when you make about 16.7 computers, forget the 0.7, that's going to be the ideal price. Now what we're going to do is just plug this in and calculate this. So we'll have 2,000 minus 60 times 16.7. So you put that in your calculator, and that'll tell you what the optimum charging price is. So 2,000 minus 60 times 16.7, that'll be $998. Okay, hopefully I create problems that are fairly reasonable. Okay, that's a typical price, maybe for some notebook computers, right? So the idea is mathematically you can model things a lot of times so you can optimize how to charge something. Does that make sense? Okay, all right. Now you deal a lot of times with revenue increasing and decreasing. That's pretty common as a model of revenue. So that's the idea. Now that problem, see, notice that problem was almost entirely done on your calculator. So if you don't have a calculator, man, you better get one before next Thursday or you won't be able to do anything on a problem like this. Okay, so get there. Okay, one more thing I'm going to do, this also we're going to do with technology, is we're going to talk about break-even analysis. You'll also see this on your test, because these are the big kind of applications that we're trying to learn in this class. So this one, what I've given you, is we're producing memory chips, that's X. I've given you a price demand function, and I went ahead and just gave you the revenue this time. And I also gave you a cost function like that, okay? So what we're going to do is, the first thing we're going to do is use our calculator to graph the revenue and the cost at the same time. I'll write down what I want you to put in your calculator. So in Y1, just put X, parentheses 75 minus 3X. You don't even need to bother multiplying that out, just put it in. For Y2, put in the cost function, which is 125 plus 16x. So go ahead and do that now. You can take out what you had in the last problem. So let's see, x parentheses 75 minus 3x, and then 125 plus 16x. Okay, get that in. Okay, now let's look at the window. All right, let me ask you, for x minimum and x max, do you know what I would want you to use for x min and max? The problem tells you, by the way. It says 1 to 20. Now I'd go ahead and just do 0 to 20, okay? So let's just go 0 to 20. And then a scale would probably be by 5, okay? And then you want to put that in. And let me show you guys this too. I'll explain this as soon as you get this put in. So I'm going to go 0 to 20 by a scale of 5. Okay. Now, students all the time on tests, a lot of times in this class say, man, I'm not getting anything on my calculator. It's your job to figure out what y is. So just do this. Notice that above your graph button it says table. So if you go second table, then you can start looking at your y values. So like if I look at my table we're only interested in x between 0 and 20. The numbers I see are in the hundreds. Okay? And if you scroll down, they're going to get bigger, then they're going to start getting smaller again. So the biggest number that I am seeing on here is like 468. That's the biggest number I see. Are you guys with me on what I'm doing there? So you're going second graph to get the table. So that's going to tell me I need my y to go up to 468. So I would go to 500. Okay? So what we're going to do then is we're going to do this. For the y, you want to go ahead and go y min is 0. And then y max, let's put in 500. And then for y scale, let's put in 100 like that. Okay, so once you get that put in, then type graph, and then we'll take a look at what we have here. So you should see a parabola and a line. All right, and that line should be intersecting that parabola in 2 points. Is that what you're saying? Okay, good. Okay, all right, so let's sketch this graph then. All right, so here's what we want to do on this then. So when you put together your graph, label x. X is million chips. I guess that's like computer chips or something. That's in millions. And that's going to go up to 20. So just go on your x-axis 5, 10, 15, 20 like that. Okay. Now the next thing is money. Okay. Now this is just talking about millions of dollars. The problem will tell you that this is going to be millions of dollars. Okay. And that's going up to 500. So we're going to go just up to 500. You don't have to label all those, but at least enough so I can tell what that scale is. All right. Now what we're going to do on this then basically is this. We're going to get a very rough picture of this graph. Okay. One thing you can do is you can either go to your table or you can just trace. What I'm going to have you do is go second graph and look at your table and just find about 3 good points, usually one at the beginning, one at the end, and one somewhere in the middle. Okay, and the y1 is going to be your revenue, and the y2 is going to be your cost. Okay, so what we're going to do is going to do this. Okay, so I'll write down what I'm seeing on here. So this is kind of what I'm seeing. I'm seeing for the revenue, I see that I have a 0.00. You'll always have that on the revenue, so you put a dot there. Okay, then I'm going to scroll a little bit further. I'm going to kind of look and see where that maximum sort of is. So I see something like, I see a 0.12 and 468. If you look at your table, you'll find that on your revenue. So I'm going to go over 12, up kind of like that. Then I'm going to go to 20 on my table and see what that is. So that's about 300. Okay, so that would be my 3 good points. So we would have that, and then you want to just label that as the revenue like that. You guys understand what I'm doing? I'm sorry I can't show this to you, but the table is where I'm getting that information. Is everybody with me there? Okay, and I'm just looking at column 1, X, and column 2, which is the revenue. Now, for your line, for your cost, okay, I'm just going to get 2 points. It's a line, so I'm going to look at 0 and I'm going to look at 20. I'm going to look at the beginning and the end. So if I look at my table, for 0, I'll have a 0.0125. And then for when you go down to 20, on that cost, we're going to see 445. And again, I'm getting that from, I'm looking at column X and column Y2. Yes. Right. I'm going to fix it, just don't ever change it. I won't even explain what I did. Okay, now you're in business. Okay, all right. That's just something, probably somebody had the computer before and learned how to do something a little differently. So that's how that's going. Okay, so what I'm going to do on this then is we're going to plot these 2 points. Plot 0, 125, and then plot 20 and 425. And it doesn't have to be perfect, just kind of ballpark. So that would be your cost like that. Okay? All right, now what we're doing on this is you're kind of looking at this like this. These two things here are called your break-even points. And what break-even points are is they're a place where the revenue and cost are equal. Okay, so it just means if the revenue you're bringing in is the same as the cost, then you're not making money, but you're not losing either, right? Okay, so that's it. This area in here is where your profit is. So it goes like this. These are your break-even points. I'm going to show you how to do that in your calculator. And this area in here, that's where the profit is. Okay, when that revenue exceeds the cost is what you do. Okay, if you've got this on your calculator, I want you to just go to the next page and do exactly what this says. And we're going to find these break-even points with our calculator. Okay, so you want your graph to be up. And then just do exactly like I'm doing here. You go second, and then trace. Now this time it's intersected, which is down there, I think, on number 5. You're finding an intersection point. Okay, press enter. Now it's going to ask you for first curve. Okay, what you want to do is you want to get close to this left intersection point. So I'm going to be pressing my left cursor key, a little bit to the left here, and just kind of get fairly close to it. Okay, press enter. Now second curve will come up and your cursor should jump to the other curve. So just press enter again. It says guess, press enter again. Then the cursor should blink on the intersection point and it'll give you that point. What's it given, by the way? What are you seeing? 2.4, are you seeing that for X? How about 163.6? Are you guys seeing that or no? Okay, try again if you have to. What you got to do is when you're doing this is you got your revenue and you got your cost. So like you got to get close to that intersection point. First curve, you got to kind of do those two things like that. Close in until you have a dot on each curve. That's the idea. Now what you want to do is you have to start over again for the next one. Okay, so I'm going to write down that first break-even point on the calculator. What we're getting is 2.4. And comma, that looks like 163.64 like that. Okay, so we have that. So what this means is, and everything was in millions. So if you sell 2.4 million chips, I think that's what it was, then your revenue is $163.64 million. Okay, that's what you got. Okay, and that would be a break-even point. So that's a place that will. Once you get past that, you'll start making profit. Yeah.
I think I did it wrong. I got 2.04 and 141, but when I was doing the curve thing with the trace, I put one before the intersection and one after. You're not supposed to do that. Right?
Yeah. What you got to do is just get close to the intersection point, and it's got to be you got to get one on both curves.
Okay.
Usually, when you do intersect, it'll come up on maybe the parabola first. Okay, try the second one. And again, I'm going to do this. You just got to try it again. So I'm going to go second, trace. Option 5 is intersect. Now see what I'm going to do is I'm going to move my cursor until it's real close to that second break-even point. Like that. So I just keep moving over there. And you want to get pretty close to it because it might not calculate it right. So wait until I'm pretty close. Now see, once I'm pretty close, I press enter. And then it should jump down to the next curve. Then you press enter again, and then guess you press enter again. So what I'm getting on the second break-even point is going to be this then. Okay, so what I'll end up getting is, second break-even point, I'm getting 17.3. Does that sound right, those of you who are doing this? Okay, and then I'm getting 401.02. So again, that means 17.3 million chips produces a revenue of $401.02 million. That's what that is. So that would be your two break-even points. Okay. If you have any question about that, I mean, you can just right after class, you can bring your calculator up and I can show you. So you just got to follow the procedure, then you get that fine. Okay. All right. So here's kind of the idea. Okay. So what values of X will you have a loss and what value will you have a profit? Okay, now I'm going to go back to the graph and just kind of show you this. Okay, loss is going to be what? It's going to be when you're less than that first break-even point. Okay, loss is also going to occur when you're after that second break-even point like that. So what you'll end up having on this is basically this, okay? We're going to kind of look at this. This is where your loss comes in. So your loss is here and it's there, okay? So what you would do is you would label this like this, okay? What values of x will loss occur? So a loss is going to occur on an interval just from 0 until you get to that break-even point, which is 2.4. So in between there, you're going to have a loss. Okay, then it's going to be from 17.3 until you get to 20, because the graph doesn't go beyond 20. That was a part of the problem. That's where your loss is. Okay, now the profit, where does the profit happen? Just in the middle of those two, right? So your profit's going to happen between 2.4 and 17.3. Now, I put those parentheses. You may be wondering, how do I know how to do brackets and parentheses? Here's how I know. Okay, first of all, 2.4, what is special about 2.4? You're not making profit and you're not losing. You're broken even. That's why I put a parenthesis. Okay, same thing there. 17.3 is a break-even point. We're not losing or gaining, so it's parenthesis. 20, why 20? Because that's the end of the interval. And same thing here. All of your profit occurs when you're a tad bit bigger than 2.4 and a tad bit smaller than 17.3. So that's how that goes. Okay? All right, those of you who have a calculator, did you follow fairly well? Okay? All right, so that you're going to have to know how to do that on a calculator. That's like a very important problem to look at with your technology. Okay, so that'll kind of wrap that up then. Okay? Okay, so I think what I'm going to do, the teacher did something really stupid.